Hello everyone. Today I will discuss about some elementary properties of equations. Algebraic function. An algebraic function is one which involves only the operations of addition, subtraction, multiplication, division, involution, and in the expressions with constant exponents. Thus, x cubed plus x square plus bx plus c under root 3x cube plus 1 twice x by thrice x plus 5 are examples of algebraic functions. Similarly, cos y e to the power x log of 1 plus y tan inverse z are examples of functions which are not algebraic, but these are transcendental. A rational function. A rational function of a quantity is one which involves only the operations of addition, subtraction, multiplication, and division upon that quantity. Irrational function. If root extraction with respect to any operand containing that quantity is involved, then the function is irrational. Integral function. Integral function. An integral function of a quantity is one in which the quantity never appears in the denominator of a fraction. Thus, ax cubed plus bx square plus cx plus d is a rational function. X to the power 1 by 3 plus x to the power 1 by 2 plus 1 is an irrational function of x. While 2yx is not an integral function. The expression defined by fx is equal to a0x to the power n plus a1x to the power n minus 1 plus a2x to the power n minus 2 plus dot plus an minus 1x plus an is a rational integral algebraic function of x of the nth degree. n being assumed to be positive integer. The coefficients a0, a1, a2 an minus 1, an are numbers independent of x. The equation obtained by putting the polynomial 1 fx is equal to a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus plus an minus 1x plus an equal to 0 is called an algebraic equation of the nth degree. Therefore, fx is equal to a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus plus an minus 1x plus an equal to 0. Is an algebraic equation. A value of x which satisfies the above equation or reduces to an identity is called a root. General equation. When all the coefficients are independent variables, the equation is called general equation of the nth degree. When all the coefficients are independent variables, the equation is called general equation of nth degree. Now, theorem. If alpha is a root of the equation fx equal to 0, then fx is divisible by x minus alpha without a remainder, or remainder is equal to 0. Proof. Given that alpha is a root of the equation fx is equal to 0, now divide the polynomial fx by x minus alpha until a remainder is obtained which does not involve x. Let Q and R be the quotient and the remainder respectively. Then fx is equal to x minus alpha into Q plus R. By hypothesis, alpha is a root, so substituting alpha for x, we have if alpha equal to alpha minus alpha into q plus r equal to 0, which gives r equal to 0. Therefore, the theorem is proved. Next theorem: if fx is divisible by x minus alpha without a remainder, then alpha is a root of the equation fx is equal to 0. This is the converse part of the previous theorem. Suppose that fx is divisible by x minus alpha without a remainder. Therefore fx is equal to x minus alpha into q, as r is equal to remainder is equal to 0. Therefore, the equation fx is equal to 0 can be written as x minus alpha q is equal to 0, as fx is equal to x minus alpha into q, which is equal to 0 means x minus alpha into q equal to 0. Also, x minus alpha into q equal to 0 is seen to be satisfied when alpha is substituted for x. Hence, alpha is a root of fx equal to 0. Thank you for watching this video.